Welcome back to my channel. In this series we shall be looking at this lecture repo of this particular GitHub, and I highly recommend the LinkedIn Learning. The guy did a great job explaining the BERT model, the attention mechanism of the transformer model. That's a good job. Yeah, so I will just be looking at some parts of what he has worked on, and try to see how to explain some other concepts from there. Uh, so this is the first in the series of that. So in today we just do a walkthrough of what we already have there. In subsequent class we'll be looking at the more details on that. So let me start just with a walkthrough of this particular Jupyter notebook, in which we use the IMDb data set to be able to do the text classification demo. We can see how you install the transformer module and the dataset module, and we did do a listing of how we can get all the different data sets that are available, the names of those data sets inside the dataset module. And also we did another example showing us how to access one of them, which is the IMDb data. So there's a lot of data set there. So he did an example on the IMDb, and you see here that because you're able to retrieve the names from here, it's easy to be able to just specify that name here, and you can see the IMDb dataset. And the way it is packaged, special class called dataset dict, and we could see the information there and how to retrieve that, and on to the training of the model. We did some preliminary preparation of the data set before it actually kick-started the training itself. Also see some exploratory data analysis there, some ETL. So there's a box plot, and there is where the model training preparation started, with actually using the tokenizer, and it did some optimization here in loading of the data by using the IMDb map function and defining a batch, defining the batch. So we will look at that in details as well, just to look at the technicalities of all of that. And here is searching the transformer model for anything starting with auto model. You can see there are so many, and in this scenario is using the auto model for sequence classification. To be a good exercise to see what the auto model for question answering, how that could work. So here is trying to do fine-tuning of that by initializing this auto model for sequence classification, and defining the checkpoint, which he has already listed up here as the distilled version of the BAT. And did a good job of showing us how to actually train that, and specifying a number of labels, moving it to CUDA GPU if one is available. And you could see how you did the preliminary work of actually just and doing your training on a smaller part of the data set, and it showed here how to actually create our own kind of data set, dict creating an instance and then taking from one instance and initializing another smaller instance, just like we have the distill part. And here is where is actually using the training argument from the transformer demonstrator. How we use that with the different parameters, and he told us that the artifact of the training is dropped into this directory, which we are going to look at what are the artifacts there, and the directory name is actually specified with the checkpoint and this alias with this name. You can see the optimizer used some log level weight decay, a batch for training, evaluation, learning rate, number of training epochs. We like to actually see if we can actually plot the training and validation loss. So these are the arguments from that, and also it showed here we see the empty cache. I think that's an optimization for the CUDA, and here is where the trainer is actually using the trainer class and it's packaging all the parameters to do the training. And we'll see the training loss and validation loss, and just for 2 epochs, and he did a prior test here, and we could see how he did the predictions and chose some metrics evaluation using the accuracy score, and how to include that accuracy score of the model on the I think that's on the validation loss. Guess that's on the validation during training. So that's why I define this get accuracy, and that get accuracy is taking predicts and it's using that to be able to make and let us know what the accuracy. I think it's a good thing to see where that particular function is built into it, because here it's just receiving threats and it's not showing us which one is it taking prediction, and the labels, is it for training or validation? That needs to be clearer. And this is the on the distill batch, and increase the batch size here, and you see how you do the login step. And so this is the training part, which include the compute metrics and includes the get accuracy, and you could see how to save the model and some little more prediction. Okay, that's just an overall walkthrough end to end of this particular Jupyter notebook, which I'm much more interested in. And in the next class, we will be looking at some important technical details of some of the libraries and how they actually work under the hood. Alright, thank you very much, and see you in the next one.